Algebra 2, 5.8b, more words translated into factorable equations. In the previous video, we did some easier ones. Now we've got some word problems that we're going to turn into equations that we can factor. And if you haven't seen the previous videos for Chapter 5, you might become confused, but you're welcome to follow along. And we learned in the last video that sometimes a problem will ask for a number x, and we'll find more than one solution for x. We can translate the words from a word problem into equations that can be factored, set to equal 0 using the principle of zero products, and solved for any value of x. If we have the square of a number plus the number is 132, the square of a number is going to be a variable squared. In this case, x squared. Plus means we're going to add. The number, again, is that variable x, and it's going to equal 132. So our equation is x squared plus x equals 132. For the principle of zero products, we add a negative 132 to each side to set it to equal 0. We then factor what we've got, and the x squared can be an x times x, and this can be a 12 times a negative 11, because when we add 12 and a negative 11, we're going to get that x, aren't we? We set x plus 12 times x minus 11 equals 0 as x plus 12 equals 0, or x minus 11 equals 0. Using additive inverses to solve for x, we get x equals negative 12 or x equals 11. Okay? So let's take a look at this one. The length of the top of a workbench is 4 feet greater than the width, and the area is 96 feet. Drawing a picture might help us figure this out. So here we've got this workbench, and we know the length is 4 feet longer than the width. So if the width is w, then the length is w plus 4, isn't it? And that's going to equal 96. Well, we know length times width is area. So that means this times this is going to be the area 96. And I put width times length, which is the same thing, in order to keep this in a distributive order, so we could distribute this w to each one. And we get width squared, the w squared, plus 4w equals 96 when we distribute that w to each term. For the zero product principle, we subtract 96 from each side, and we get w squared plus 4w minus 96 equals 0. Now we can factor this. So we look at this w squared, and we know that w times w makes w squared. This can be a 12 times a negative 8. We try to find the factors for negative 96, and it could be any one of these, but it's got to equal a positive 4. And none of these equal a positive 4 until we do a negative 8 plus a 12. So now we know a negative 8 and a 12 is what fits there. So we've got w plus 12 and w minus 8, see? And we set it to equal 0. Then we set w plus 12 to equal 0, or w minus 8 to equal 0. When we use our additive inverses to solve for w, we get w equals a negative 12, but that can't be because a width can't be a negative, can it? So the width is not a negative 12. Or we get that the width is an 8. Well, yeah, because if we substitute this into the equation, we're going to get, the solution checked out, and it's going to equal it. And if we look at the width being 8, if the length is the width plus 4, that means the length is 12. So we know the width is 8 and the length is 12. Okay? So sometimes common sense will step in and we'll say, well, wait a minute, a width can't be a negative, right? All right, let's check out this one. This is kind of popular. The sum of the squares of two consecutive odd positive integers is 202. Well, the sum tells us we're going to have to add them. And two consecutive odd positive integers would be an x and an x plus 2. But it wants the squares of the two consecutive odd positives. So now we've got x squared plus x plus 2 squared. So x is the positive integer, and x plus 2 is the next positive integer. Like if x was a 3, the next positive odd integer from a 3 would be a 5, wouldn't it? So wouldn't that be the 3 plus 2? If you're confused about this, you need to go and see Algebra 1 3.11b, and there's going to be a link in this video's description to show you how to do consecutive even or odd integers, okay? So I'm going to assume that you know how to do that, and we're going to continue on. So now we've got this x and x plus 2, but it wants it to be squared. So we've got x squared plus x plus 2 squared equals 202. All right? So this is a square, isn't it? So we can FOIL this, and we're going to get this x squared plus 2x plus 2x plus 4. And that's going to equal the 202. We can combine these like terms. This is going to be a 2x squared, and this is going to be a 4x. And it's going to equal plus 4. We can't forget that 4, can we? Is going to equal the 202. So now here comes the tricky part. This is where everyone gets confused. So we've got this 2x squared plus 4x plus 4 equals 202, all right? And we're going to set it to equal 0 with the principle of zero products. So we're going to subtract 202 from each side, and we're going to get 2x squared plus 4x minus 198 equals 0. Because when we take that 202 away from that 4, we get a negative 198. So here's the confusing part. Every coefficient here can be divided by 2. You can think of it as you're factoring out the 2, but every coefficient can be divided by 2. See, we're not dividing that x squared, we're dividing the coefficients, okay? So that's going to give us an x squared and a 2x and a minus 99 equals 0. Now we can find factors for minus 99 that are going to equal 2 when they're added together. And we can make a big list like this of all the factors. But 9 times 11 is 99. And in order for it to be a negative, one of those factors has to be a negative, but they have to equal a positive 2. So we come up with an 11, a positive 11, and a negative 9. That would equal 2 when added together. So now we've got x plus 11 and x minus 9, and it's set to equal 0. We split these apart as x plus 11 equals 0 or x minus 9 equals 0. We use additive inverses to solve for x. We get x equals a negative 11 or x equals a 9. Well, it told us in the problem that they were consecutive odd positive integers. So can it be a negative 11? No, it has to be a positive integer. So it's not this one. How about 9? Yeah, if x is a 9, then the integers are 9 and 11 because we have x as 9, and then x plus 2 would be 9 plus 2. So 9 and 11 would be our answers, okay? So remember that we can divide all the coefficients by a common factor, okay? Like we did here. It made it smaller and easier to factor, didn't it? Okay, our next video, 6.1a, we're going to talk about how to simplify rational expressions. I'm going to add this video to the Algebra 2 playlist so you can study and review, and all the pertinent Algebra 1 videos, like that one for consecutive even or odd integers from 3.11b in Algebra 1 is going to be in here, plus all of these for factoring from Algebra 1, and the previous videos from Chapter 5. So it's going to be a really long list of videos in this video's description that you can click on, okay? It'll help you study, all right? So I hope you were able to figure this out, and I hope it was helpful, and I'll see you next video. Bye.